Hi, my name is Jenna Bakandi, and today I'll be doing a short review of Section 12.1, Congruent Triangle. Section 12.1, Congruent Triangles. Congruent triangles. Two triangles are congruent if their corresponding sides are equal in length and their corresponding angles are equal in measure. As you can see here in our example, both sides on both triangles are equal, and they both have an equal angle as well as the equal sides. So that means that these two triangles would be considered congruent. Examples of congruence. Here I have two triangles for this example. Let's just assume that these two triangles are congruent. So we want to assume that ABC is equal to DEF. So here we want to try to find our corresponding angles. Now, assuming that these are all equal, angle A would be equal to what angle in this? We'll call this triangle 1 and triangle 2 for all these purposes. So if we want to find the angle of A, we would want to find the corresponding angle. And our corresponding angle would be D. So our corresponding angle to angle A would be angle D. Now, if our corresponding angle A equals D, our corresponding angle for B would be E. So corresponding angle for B would be corresponding angle E. And if A equals D and B equals E, we want to assume that angle C equals angle F. Now we want to try to find our corresponding sides or line segments. And again, assuming that the triangles are congruent, if we look at our line segment A to B, we assume that that means that angle D to E would be the same. And if you look at our angles A equals D, so if you're looking for the line segment A equals B or AB, you would assume that it would start with D, and if B equals E, it would end with E. So that's two different ways that you could try to find a line segment. So if we want to find line segment AC, it would be FD or DF. So again, so we look at angle A, it would be equal to angle D, so we start out with D, C would be equal to F, ends with F. And that's how you can double check that again. So if AB equals DE and line segment AC equals DF, we can assume that line segment BC is equal to line segment EF. And that's how you'll find your corresponding angles and corresponding sides or line segments for congruent triangles. Now I want to go over the different ways you can prove congruency in triangles. There's 4 different theorems for this proving of congruency. Let's start out with the SSS rule, or otherwise known as the side-by-side-by-side rule. Now this rule states, if 3 sides of one triangle are equal to 3 sides of another triangle, then they are considered congruent. Now let's look at the SAS rule, or side angle side. Now with this rule, it states that if 2 sides and the included angle of one triangle are equal to 2 sides and the included angle of another triangle, then they are considered congruent. So this is when it's going to have 2 equal sides for each triangle and the angle that's in between these 2 sides, the included angle. Now let's review the ASA rule, which is otherwise known as the angle side angle. This states if 2 angles and the included side of one triangle are equal to 2 angles and the included side of another triangle, they are considered congruent. This is when you're going to have one side that's in between 2 equal angles in 2 different triangles considered congruent. Again, a side that's equal in between 2 equal angles of 2 different triangles. Now let's review the AAS rule, otherwise called the angle-angle side. This theorem states if two angles and the non-included side of one triangle are equal to two angles and the non-included side of another triangle, they are congruent. Now in this case, this is when you have two equal sides and a side that's not in between the two equal angles. This is again when you have a side that is equal in the two triangles, but it's not in between the two equal angles of each triangle. I have 4 different examples for all 4 different rules that we just reviewed. Again, just a reminder, we have the SSS rule, which is side, side, side. All 3 sides are equal. We have the SAS, which is the side, angle, side, where 2 sides and an angle are equal, that's included. We have the ASA rule, angle, side, angle, where you have 2 equal angles, two equal angles, and a side included that is equal on both triangles. And we have the AAS rule, where we have 2 equal angles and a side that's not included equal to different triangles. So let's try to pick out which examples are equal to these rules. Now, if we look at number 1, we have what looks like 2 congruent triangles. And we can look from these symbols. They have 1, 2, and 3 equal sides. So that means that all sides are equal. So to see the rule that proves that these triangles are congruent would be the side, side, side rule. So for number 2, we could see from these signs that we have 1 equal side, 2 equal sides, and we can see that we have an equal angle. Now to pick out which rule proves this congruency, we have to remember that we have side, angle, side, and then we have angle, side, angle. Now, this has 2 sides, so obviously it's not going to be angle, side, angle. It's going to be side, angle, side, and it has an included angle, which means it would be the SAS rule, or side, angle, side. Number 3. We have 2 angles and an equal side for each triangle. So we would have an angle, side, angle. So that means this would be our ASA rule, or angle, side, angle. And remember, this means that we have to have an included side, so that would be ASA. The AAS is the one that has the non-included side. And we could see that example in number 4. We have 2 equal angles and then a side. And the side is not in between the 2 equal angles, so we can already assume that this is going to be angle, angle, side, or angle, angle, side. Now, if we take everything that we just reviewed and learned, we know that corresponding segment and angles are equal when they are congruent to another triangle. So let's put actual numbers in here. Here I have an example triangle ABC. I filled in the line segments, lengths, and the degrees of each angle. For this problem, I want you to suppose that triangle ABC equals triangle DEF. Now, this is a hypothetical triangle, but we are understanding that is congruent to triangle ABC, which means that they'll have equal angles and line segments, or sides. So for this problem, I want us to try to find these congruent sides and segments and angles. So first, we want to try to find line segment DE. Now remember, this is a triangle that is congruent to ABC. So if angle A is equal to angle D, we would assume that angle D would start here where angle A is. Now, if we're trying to find line segment D to E, we want to go BE. So that means going to go from A to B, D to E. So we would assume that line segment DE would be line segment AB. So our length of line segment AB would be 4. So our answer to this problem is the line segment DE would be equal to 4. Now we want to try to find number 2. line segment FD. Again, we want to go down here and look at our congruent triangles. F is going to be equal to line or angle C. So F would be here. Now we have line segment F to D. So we're going to go from F to D, and angle D is equal to angle A. So we're going from F to D, C to A. So our length of line segment F to D would be 5. Now we want to try to find the corresponding angles. The first problem I want to do is number 3, which would be the angle of D. Now remember, the triangles are corresponding, so that means that angle A would correspond to angle D, and the angle measure of angle A is 16 degrees, which would mean that angle D would also be 16 degrees. Now we want to look for number 4, angle F. Again, angle F would correspond to angle C. Angle C's degree angle would be 28, so angle F would be 28 degrees. Great job! Elfin, that's the end of my short review on section 12.1, congruent triangles. Thank you and have a wonderful day. Bye!